Big Soft Ed presents Subtraction. When subtracting two large numbers, you can put one number above the other with the digits neatly aligned in columns, then subtract each digit on the bottom from the digit above it. And you get the answer to the whole question. This works no matter how many digits there are, or even if the numbers have decimal points.
Get in line, lovely boys, move yourselves.
It stops working if any digit on the top is smaller than the digit underneath it. Then we have to do a little meddling. What meddling we do depends on what method we're using. There are two in popular use. I'm calling them borrow and payback, and decomposition. In borrow and payback, the solution is to look at the digit that's too small, wish it was bigger, then magic 10 out of thin air to add on to it. Okay, it's not magic. It never is. What we actually do is borrow 10 from the maths bank, I guess. We add our shiny new 10 to the digit that's too small and, hey presto, now we can carry on with the subtraction. Ah yes, but it's not magic. We've borrowed something, so we have to pay it back, and we do that by making the digit on the bottom of the next column larger by 1. How you write that 1 payback is up to you. You could cross out the 2 and write 3, or as shown here, just put a small 1 nearby. But be sure to write it differently to the way you added 10 above, otherwise it's just confusing. It might seem like cheating that we pay back with a number that also seems to come from nowhere, but it's allowed because by making the bottom number a bit bigger, we subtract a bit more, which cancels out making the top number bigger. It also might seem strange that we're paying back with a 1 when we borrowed 10. That's because we pay back into the next column along, where everything is worth 10 times as much. It's like borrowing 10 £1 coins and paying back with one £10 note. Now we can work out the answer. For the first column, 12 subtract 8 is 4. When we come to work out the subtraction in the next column, that small 1 means we're working out 5 subtract 2 plus 1, so 5 subtract 3, leaving us with 2. 52 subtract 28 is 24. Let's look at a problem where we have to borrow and pay back more than once. We can't subtract 9 from 5, so we borrow 10 to make the 5 15. We pay back to the 7 on the bottom in the next column. 15 subtract 9 is 6. Now that the 7 on the bottom has been increased to 8, we can't subtract it from the 7 above, so we borrow another 10 to make that one 17 and pay back to the 4. 17 subtract 8 is 9, and finally we're now subtracting 4 and 1, so that's 5 from 8 to leave 3. Now let's take a look at how decomposition approaches the original problem. The name isn't so much about something rotting as it is breaking something down into simpler parts. Sorry if that disappoints you.
Come on!
As before, we can't subtract 8 from 2. But decomposition says, why borrow 10 from an imaginary bank when in the column next door there's a big pile of 5 10s just sitting there? If we take one of those 10s and add it to the 2, we can work out the subtraction. So our starting number of 52 now reads 4012, and that 12 means we can subtract the 8. A problem occurs in a subtraction like this. We need to increase the 5 by 10, but when we look to take 10 from the column next door, we find there's literally nothing there.
Okay. Disappointed!
But that's okay, we can just take from the column next to the empty one. What we can't do is take the 10 back across 2 columns to where we're working. We can only add it to the next column on the right, the 0, to make 10. You might like to think about why that is.
Pause for thought.
Once we've dropped off our 10 where the 0 was, we have something to decompose and carry to the 5. 705 has become 690.15. It might seem a lot of work, but now we can complete the question with no more messing about. If you find two zeros side by side, you have to go further still to find something to borrow. It still works, and once you've done it a few times, you'll probably find your own shortcut for writing it out quickly. Then again, you'll probably find there are better methods for solving that sort of question than either decomposition or borrow and payback. So, which is easier? Here are a few things to think about when comparing the two methods. Traditionally, borrow and payback has less crossing out. In fact, it usually consists of just putting little ones everywhere. The working for decomposition is more destructive, making it harder to reread the question when you're done. But decomposition also only affects the top number of the calculation, while borrow and payback meddles with both top and bottom numbers. Borrow and payback never has you looking further than the next column, while in decomposition, where there are zeros in the top number, you sometimes have to work across several columns. This makes borrow and payback easy to do in your head. Decomposition doesn't have digits appearing out of nowhere though. It only uses the numbers you're given at the start. Borrow and payback's approach of plucking figures out of thin air or borrowing from an imaginary bank can seem rather strange. So which is easier? Usually the one you first learned, as a habit is hard to unlearn. I learned decomposition first, but now I'm comfortable with the mathematics behind both methods. I rather like borrow and payback's simplicity. If you're familiar with one of these methods, why not give the other a try? And thanks for watching. Take it away, Ed.